Hello, my ninja warriors. Welcome to yet another power packed session. And today we are going to discuss all the previous year question, or you can say recent year questions of April attempt JEE Main 2024 from the chapter Differentiation. Now, you must be wondering that differentiation, ma'am, every time I start any chapter, you have one thing. Ma'am, what is the weightage of this particular chapter? So, right here, you can see that in April attempt, there were 6 questions were asked from this chapter and 5 questions were asked in January attempt. What does that mean? 6 question, 5 question, but like how to calculate the weightage of it? So it is very easy. 10 questions papers were held in January as well as April attempt. So clearly that 6 question means that out of 10 question papers, 6 question papers were having single question and rest four remaining 4 question paper were having no questions from differentiation. That means this is a low weighted chapter, but this is a scoring chapter because differentiation is very easy because you have learned differentiation in physics as well. That is number one point. Number two, without differentiation you won't be able to do anything in calculus. So that's why this is very important topic as well. Important, less weightage together, right? So yes, let's just start with the very first question. All 6 questions we are going to do right away. So the very first question is from the topic which is my favorite and NTA's favorite, J Advanced favorite topic as well. That is differentiation, differentiation of inverse of a function. This I have already told you, right? That this topic is the most important or most impactful topic. If somebody asks me, okay, that ma'am, give one question from differentiation, I will definitely give that question from this. Okay. Yeah. So in this question, fx is given and there is a function gx in such a way that gof x is equals to x. Okay. That means basically g and f are inverse of each other. So sometimes they do not give gof x equals to x. Sometimes they just tell you g is equals to f inverse or f is equals to g inverse. Okay. So if they at all give you that condition also, that also means that g of f of x is x. Now we are here looking for 8g dash 2. That means we are looking for derivative of g, right? Derivative of g, that means derivative of f inverse because uh, g and f are inverse of each other. So that is the point. How to do it? This I have already told you in row series. I hope that you guys are watching row series. Okay. So write g of f of x equals to x. Now differentiate using chain rule. So g dash f of x into f dash x is equals to 1. Correct? Now you're looking for g dash f of x will be equals to 1 upon f dash x. Correct? Now what are you looking for? Just tell me. You are looking for g dash 2. That means you want 2 inside g dash, right? You want 2 inside the g dash, right? So you want 2 over here. You want 2 over here. Just plug in 2 over here. That means you're looking for fx becoming 2. Now you need to think about when exactly will fx become 2. Okay. So so x raised to power 5 plus 2 e raised to power x by 2 should be equal to 2. Now it is very obvious just by hidden trial. Put x equals to 0, 1 plus 1 minus 1. The moment you put x equals to 0, you get left hand side equals to 2. That means f of 0 will give you 2. What does that mean? That in here you have to put x equals to 0 everywhere. G dash f of 0, correct, is equals to 1 upon f dash 0. Correct. Okay, and now g dash f of 0. So g dash f of 0 is 2. So let us write 2. That's what you wanted. Upon 1 upon f dash 0. Now f dash 0, how to calculate? By just differentiating fx. Fx is already given to you. Very easy, right? You're very close to your answer. Correct? F dash x will be equals to 5x ki power 4 plus 2 e ki power x by 4 into 1 by 4. So now put x equals to 0. So you get f dash 0 equals to, this is 0 plus e raised to power 0, so 1 by 2. F dash 0 is 1 by 2. So 1 upon 1 by 2. Be careful. Okay, sometimes 1 by 2, so you will be going and taking 1 by 2. Don't do that. 1 upon 1 by 2, that is 2. 2. Option A is absolutely right. I guess this is fine. Now let us talk about the next question wherein the higher order derivative y double dash is asked. Y dash, y double dash and y. These three values we want at theta is equals to pi by 2. So this question is very simple over here. It might be a little bit lengthy because of the simplification, okay? First of all, we need y at pi by 2. Let's calculate that. Y of pi by 2. That means you're plugging in theta is equals to pi by 2. So 2 cos pi by 2. So 2 into 0 plus cos 2 pi by 2. So cos pi is minus 1. Upon cos 3 pi by 2 again 0 plus 4 times cos 2 pi by 2. So cos pi minus 1. Then 0 again plus 2. So you are going to get minus 1 upon 2 minus 4 is minus 2. So half. This value is half. Okay, now what we need to do is y of theta we need to a little bit simplify. 2 cos theta I will keep as it is. Cos 2 theta will be 2 cos square theta minus 1 whole upon. Now cos 3 theta will be 4 cos cube theta minus 3 cos theta whole upon plus 4 cos 2 theta 4 2 cos square theta minus 1 plus 5 cos theta plus 2. Perfect. Y will be equals to now 2 cos square theta plus 2 cos theta minus 1 whole upon. Then we are going to have 4 cos cube theta. Then, okay. So this is 4 cos cube theta plus 8 cos square theta minus 3 to plus 2 cos theta. And the constant term will be minus 2. Perfect. So now y will be equals to, okay, so clearly 2 can come out. Okay, 2 can come out. Is it? Just give me a 4 cos cube theta minus 3 cos theta plus 4 to the 8 minus 4. Minus 4 plus 2 is minus 2, correct? Okay. All right. Okay, yeah, 2 can come out, definitely. So 2 can come out, and after taking 2 out, if you just split the denominator, no, what you will get is cos theta plus 1 and 2 cos square theta plus 2 cos theta minus 1. This is again 2 cos square theta plus 2 cos theta minus 1. Now you must be wondering, ma'am, what did you just do? Basically, what I did is denominator is this 4 cos cube, 8 cos square, right? This is your denominator. 4 cos cube theta, 8 cos square theta. Then we are having again 2 cos minus 2. So I have taken 2 common, correct? So 2 cos cube theta plus 4 cos square theta plus cos theta minus 1, correct? Then hit and trial. You have to put cos theta is equals to maybe 1. It will not work maybe. Cos theta equals to 1. 2 plus 4, obviously 1 will not work. Cos theta equals to minus 1. Is it satisfying? So it is going to be minus 2 plus 4, and that is going to be 2 and minus 2. Yeah. So cos theta is equals to minus 1 satisfying. That means cos theta plus 1 can be a factor. Now what you need to do is you need to divide this whole 1 plus cos theta plus 1. Cos theta plus 1, you divide by long division 2 cos cube theta. You can assume x also, cos square theta plus cos theta plus 1. If you divide, what will you get? First of all, 2 cos square. Divide. What will you get? Tell me. So you get 2 cos theta square. So 2 cos cube theta plus 4 cos square theta. Subtract. This is gone. This is also gone. So cos theta plus 1. Now plus 1, right? So you're going to get, okay, 2 cos cube and so this is going to become, correct, 2 cos square, 2 cos square plus 1. Okay, plus 2 cos square. So this is 2 cos square plus cos theta plus 1. So this is again plus cos theta you will need, right? So yeah, if you divide them, then you will get 2 cos square theta plus 2 cos theta minus 1. Yeah, factorize it, okay? So yes, this is what your denominator is. Clearly, these two are getting cancelled out. So y is coming out as minus 1 by 2, 1 plus cos theta. Now this is your y, by the way. Okay? So you have to differentiate it. Y dash will be equals to minus 1 by 2, 1 plus cos theta whole square. Derivative of cos theta is minus sin theta, right? Now put theta is equals to pi by 2 right here so that you get y dash ka value. Okay, so this is going to be y dash is equals to 1 upon 2. That's it, 1 by 2. This is also coming 1 by 2. Interesting, interesting. Now y double dash. To get y double dash, what we are going to do that is, okay, for y double dash, we need to write y dash, which is sine theta upon 2, 1 plus cos theta whole square. Now y double dash, the quotient rule. 2 is already there, 1 plus cos theta whole square ka square, so that is power 4. Correct, and 1 plus cos theta ka square as it is, sin theta ka derivative is cos theta minus. This time sin theta kept as it is and the derivative of this is 2, 1 plus cos theta, and again this is going to be derivative of cos theta is minus sin theta. Now quickly put. So this is going to be 1, this is going to be 0. Done. So this is 0. Sin theta is again 1. This is also 1. This is also 1. So 2, that's it. 2 upon 2. So y double dash is coming out as 1. All right. So clearly y double dash is 1. So that means the final answer of this question would be, okay. Okay, so this is going to be 1 plus half, clearly option C, right? 1 plus half plus half. Option C, 2 is absolutely right. Next question on your screen right away. Okay. So this question again, double derivative they are asking. So one by one, we just need to differentiate. Okay. F dash x, tell me. When x is not 0, obviously. Right. So when x is not 0, then we need to talk about f dash x. Okay. So f dash x. Tell me, tell me. So this is 3x square, right? And sine 1 by x. So basically, product rule I'm applying, wherein sine 1 by x is kept constant, x cube derivative is 3x square plus. This time x cube is constant and cos 1 by x is there. Also, derivative of 1 by x square is minus 1. Okay, f dash, I don't need f dash x. But let us rewrite f dash x properly. So 3x square sine 1 by x minus we are having x cos 1 by x. Again, two product rule formulas will be applicable. Let me just calculate f dash x right here. So 3x square is kept constant. Sine 1 by x derivative is cos 1 by x minus 1 by x square. Plus this time sine 1 by x kept constant and 6x minus. Now x cos 1 by x, correct? So x is kept constant, cos ka derivative is minus sine. So minus sine 1 by x and minus 1 by x square. Okay. Plus because product. This time cos 1 by x as it is and derivative of x is 1. That's it. Now what you need to do is f double dash x is coming out as 3x square. Okay. Minus 3. Oops. Minus 3. That's it. Minus 3 cos 1 by x. Correct. Then here we are having plus 6x sine 1 by x. Correct. Minus, this is minus becoming plus, and this is going to become 1 by x sine x. Minus plus minus again, cos 1 by x. That's it. This is your final. And these two are again like terms. So yeah, this is minus 4 cos 1 by x. Now you're looking for f double dash 2 by pi. Let's put 2 by pi, okay? If you put 2 by pi over here, so 1 by x, see, if x is 2 by pi, so obviously 1 by x will become pi by 2. So cos pi by 2 is again 0, so these two terms are gone. Then 6x, so 6 2 by pi into sine 1 by x will be 1 minus, then this is 2 by pi again, that's it. So 12 minus 2, 10 by pi. Any mistake I have committed? Okay, 1 by x. All right. So f double dash 2 by pi will be 12 by pi. Okay, and this is okay. All right. 12 by pi correct minus this is 1 by x. So this is pi by 2. So sorry. This is pi by 2, right? The second term is pi by 2. Yeah. Now it's right. So now if you solve, this is 2 pi to 24 minus pi square. So yes, I don't think so. We have to do this and this, right? Because 0 beta is not even differentiable. So f double dash 2 by pi is coming out as 24. Option A is clearly correct. All right. Now we are having another question. Question number 3. Quickly, we are actually completing all the question. Very like little number of questions in this chapter. All right. So differentiable function h of 0 is 0. H of 1 is 1. H dash 0 and h dash 1 both are 2. Multiple things are given to you and they are talking about this, which is gx is given, g dash 0 is what you're looking for. So chain rule, g dash x, two functions are involved. Let us mark it as first and second. Now first function kept constant, derivative of second function is e raised to power hx, h dash x plus, this time e raised to power hx is constant and the derivative of h e of x is h dash e power x and e power x derivative is e power x. Now you put x equals to 0. So g dash 0 will be equals to h. E ki power 0 is 1. Okay. E h of 0. H of 0 is what? 0 given in the question. H dash 0. H dash 0. Okay. H dash 0 plus E. H of 0 is 0. H dash now e power 0 and this is e power 0, right? So g dash 0 will be h of 1. Where is h of 1? 1. So 1 multiply e ki power 0 is again 1. H dash 0 is 2 plus e power 0 is 1 multiply h dash e power 0. H dash e power 0. H dash 1, that's it, h dash 1, h dash 1 is 2 again, multiply e power 0. So 2 plus 2, 4 is the correct answer of this question. The option B, absolutely killer question. Like easy peasy lemon squeezy, alpha question. Now again, the next question is here, which might look, which is looking like it might consume some time of ours, right? Fx is given like this. F of 1 is 40, f dash 1 is 2, f dash 1 is 4, a square, b square, c square ka value they are asking. Okay. So now let's start differentiating. F dash x is 3ax square plus 2bx plus c, correct? Put x equals to 1. The moment you put x equals to 1, you will get f dash 1, that is 2. So 2 equals to 3a plus 2b plus c, first equation. Okay. X equal to, put now, hold on. F dash 1 they are giving 2 and f dash 1 again 4. Hold on, there seems to be some mistake. I guess this is f double dash, right? Now let's differentiate second time, f double dash. So 6ax plus 2b. Now you put x equals to 1 again. F double dash 1 equals to 6a plus 2b. F double dash 1 is given as 4 is equals to 6a plus 2b. Second equation. And let's not forget, because f of 1 is given as 40. That means a plus b plus c plus 41 is given as 40. So a plus b plus c is given as -1. This is your third equation. Now you have to solve these two equations. That's it. So a plus c, can we just write the value of c here? है ना? So a plus b plus c. C can be like calculated from here. So C will be 2 minus 3a minus 2b. That is going to become -1, right? So minus 2a and minus b. Okay, this is going to become -3. So 2a plus b equals to 3, right? 2a plus b equal to 3, correct? Okay, and now 6a plus 2b is equals to 4. So 3a plus b is equals to 2 by the second. Subtract. So a will be equals to -1. If a is -1, so b will be equals to 5. A -1, b 5. If you put it over here, so 5 minus 1 is 4. So C is -5. Okay. All right. So basically your A is coming out as minus. Okay. Yeah. So A square plus B square plus C square will be 1 plus 25 plus 25. So 51. Where is 51? Option C. 51 is absolutely right. Okay. All right. This question also done nicely. And now we are having. Uh, 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 I didn't realize. Is this our last question? Yes. Okay. Log y is 3 sine inverse x. Correct? And we are looking for this expression at x equals to half. Acha. Okay. All right. So let's start differentiating. I guess I need y dash and y double dash. All right. Let's do that. 1 by y dash will be 3 square root 1 minus x square. Perfect. Now cross multiply. Y dash square root 1 minus x square is equals to 3y, and differentiate one more time. So y double dash. Okay. So first of all, differentiate with respect to x first time, and after cross multiplication again differentiate with respect to x second time. Perfect. Y double dash 1 minus x square root kept constant, plus this time y dash is kept constant, and square root 1 minus x square is differentiated. So 1 by 2 root 1 minus x square, and this is going to be minus 2x. Correct? 3y dash x, sorry, not x. 2 cancel out. Right. So y double dash, let's take LCM also, no? 1 minus x square minus y dash x is equals to 3y dash square root 1 minus x square. So can you see we've got this? Clearly that the LHS is what is asked from us. 1 minus x square y double dash minus xy dash and RHS. So that means we just want the value of y dash at x equals to half. This expression is equivalent to the right hand side, right? Y dash we are looking for. So first of all, tell me, your log y is 3 sine inverse x. Tell me, if you put x equals to half, what will you get? So ma'am, log y is equals to 3. Sine inverse half is pi by 6. So pi by 2. So y is equals to e की power pi by 2. First of all, you're getting this. Y is equals to e raised to power pi by 2. Now, just tell me about this. Y dash is equals to 3y upon square root 1 minus x square. Right? 3y. Y at x equals to half. So at x equals to half, your y is coming out as 3 e power so pi by 2 whole upon square root of 1 minus 1 by 2 whole square, so 3 by 4. So this is going to be 3 by root 3, and it is 2 e raised to power pi by 2. So y dash, now we are having 3 6 e raised to power pi by 2 upon root 3, and this square root 1 minus x square is going to be again under root 3 by 4. Root 3 cancel. 4 is becoming 2. Root 4 is 2. So this is 3. So 9 e raised to power pi by 2 is absolutely right. Let us check which option is matching. So I guess option B is matching. So I guess this the chapter we have nailed it. Differentiation now you know. So this chapter I don't suggest that you skip this chapter because this is a low weighted chapter. No, because this one question and all the questions were very easy. You see how much time it took us to complete this whole thing. Very less, right? Okay. And also, I would like to tell you about the Roar series, number one. Okay. So let's just go and watch the Roar series. So many chapters have already been completed. So one shot detailed with latest PYQs, JEE Main and Advanced has been updated. Okay. Updated detailed one shot for your preparation of JEE Main, concept clarity and everything. Second, 2024 PYQ, so we already are doing it, right? Second thing is, um, are that JMIN 2022 and 2023 PYQ. Where to get this? And especially the chapter wise PYQ. If you want the chapter wise PYQ, I will highly recommend you go for Tatva series, right? The link is given in the description box. Chapter wise PYQs, detailed solution, error free solution, and the books are very handy. So just check the description box and you can just purchase that book. Okay. Also, if you have any doubts or any confusion, you can reach out to me on my Telegram channel t.me/Namrata Jaisinghani. Okay. All right. So from my side, I'll be leaving now. I'll be taking your leave. And now I'll be seeing you in the next video. Also, comment below and tell me that which PYQ do you want to see next in this particular series. Okay, so I'll be reading out your comments and accordingly I'll plan my videos. This is me, Namrata, signing off. I'll see you all in next video.